Particle motion free response question. Um, this is a calculator section on a trig function. So a particle travels on a number line with position given by s of t equals t sine of t for t in the interval, the closed interval, 0 to 2 pi. Find the velocity and acceleration functions. And we're going to go back and forth to this thing. This is what I want to make sure that I tell you. First off, on the calculator section of free response, you need to explain your answers well through notation. You can't, please, never write, I got the answer by using my calculator, because it's really the same as you saying, please don't give me any points. So let's do this problem. Maybe you can just write down the first part, and we'll take this function and we'll try to find its first derivative. All right? So it will look like this. So let's go straight out to calculator. So here's our calculator. This is a Ti CAS CX. The Inspires won't do all this stuff, but let's go here and let's go to Insert Calculator. And then what I'm going to do here is this. I'm going to go to Calculus. Actually, I'm not going to do that yet. This is what I'm going to do. I'm going to put the function in, and I'm going to save it because I'm going to need to use it later. So instead of putting t sine of t, if you don't mind, I'm going to use x times sine x. Right? This is going to be really, really helpful, I promise, if you stay with this. Sine x. Make sure it looks the way you want it to look. And then hit Control Store, and then say this. What I usually do is I take the function I call f of x, its derivative I call g of x, and the second derivative I call h of x. So here's that. Okay? So far it might seem like, why do I need to do this? But I promise you in a minute we're going to come back to it. The next thing I'm going to do is this. I'm going to go back to menu. So for you that's here. It will take you to here. I'm going to go to calculus now, and I'm going to take derivative, not at a point, just derivative. Remember that you can't mix these metaphors, so we have f of x, so this has to be d dx. And I want the first derivative of f of x, so I don't have to type that function in again. I just type in f of x like that. Hit enter here. Okay, so this is our first derivative, so I'm writing that on my paper right now, and I'm going to move on. And what I'm going to do here is I'm going to take Control, Answer, and then I'm going to save that as g of x. So I'm saving my first derivative as g of x, and you're going to see why this is really important in just a minute. Right? If you want to, from there, if you want to, you can take the second derivative. But as I looked at the problem, you don't really need, well, we need the second derivative. I guess we definitely need it. So let's do that. You go to menu here. Right? Go to here. Calculus, derivative, same thing again, right? All I'm doing is collecting the stuff to write it on my paper, and I want the first derivative of g of x. Remember, g of x is the first derivative of position, so this is the second derivative. So I'm going to write that down, 2 cosine x minus sine x. Remember that these should be written in t. So far, so good? Okay, now what I'm going to do is just going to leave here just for a second, and I'm going to go back and find this particle motion problem. I'm just going to write these answers in. So this is pretty straightforward here, but this is the notation I want to use. I want to tell my reader that velocity is the first derivative of position, and that was t cosine t plus sine t, right? And then they ask us to give them the accelerate, right? So this is velocity, that's v right here, and now we need acceleration. And we know that acceleration is equal to the first derivative of velocity, or the second derivative of position. And then we got that off the calculator, so it was 2 cosine t minus t sine t minus t. Oops, sorry, minus t sine t. We didn't have to prove that work, but here it is. It says, for what values is the particle at rest? So what we want to know is, when is g of x equal to 0? Because remember, g of x for us, actually what we want to know is, when is v of t, velocity, equal to 0? So that's what we're going to do now. So we're going to go find that here, and this is how I'm going to do that. There's more than one way to do it. You can use the solve function on your calculator, which will work really well, except for the fact that we have a sine function, so it has this, right, it does this, and it's periodic, so it's going to show up over and over, and we only want to know the answers between 0 and 2 pi. So what I'm going to do is this. I'm going to go back to the calculator, right? I'm going to go to Insert, I'm going to go to Graphs, and then what I'm going to do here is, instead of retyping all that crap, I'm just going to type in g of x. And at first, this won't look very helpful. That looks like hell, doesn't it? But remember, we only care, right? We only care about this, right? We only care about this from 0 to 2 pi. Isn't that right? That's what they gave us as the interval, 0 to 2 pi. We want to know when that thing hits 0. So what we're going to do is this. We're going to go to menu again. And I get this is kind of a pain in the neck, but this is going to get easier the more times you do it as you practice this. So what I'm going to do is I'm going to go to menu, right? Menu, you'll see this. And then I'm going to go to window. I'm going to go to settings here, and then I'm going to type in 0 to 2 pi. So 0, and your calculator does recognize the word pi, 2 pi, and hit enter. First off, that makes it look a lot better, doesn't it? Now, right, so take a second and take a note on this. Go back to your menu, and I'm going to hit this points. I want points on, right? I want points on this thing. And look, there's the intersection point. Bang, got one of them. Go back to points, points on. I want it on this function. Sorry, didn't need that point at all. You know, I'm going to mess with it. I'm going to go back and fix this. Do it again. Right. Point of intersection right there. Right? So now I'm just going to record that onto my paper that we have zeros at 2.03 and 4.91. Now check this out for a second. This is all going to really come together in just a second. So I'm going to go back to this. I'm going to go back to our paper here, right? To this, show that, right? It says, what values is it at rest? Well, we found those points at t equals 2.03 and t equals 4.91. And these are seconds. They're really sticklers for this kind of stuff. So make sure you write that. It says here, draw a path. Draw a path. So this is how this works. And it's not bad at all. I'm going to gather some places up here. So what I'm going to do here is this. I want to know what, I need to know what the position is. What's the position at 0? What's the position at this? What's the position at this? And remember, what's the end of the thing we're interested in is 2 pi. So this is what I'm going to do here. I'm going to go back to the calculator here, go to insert, and if you're going, holy crap, this is so much stuff, try to do it by hand. It's just impossible. So this is actually much faster. This is a 15-minute problem, and I'm explaining it to you as we do it, and still it's going to take less than that. So I want f of 0. F of 0 is 0 because that's our starting point, isn't it? We want f of, remember we had a 0 at 2.03, so f of 2.03, because we know here, we know here that the velocity goes to 0, but we want to know where are we when the velocity goes to 0, and so we hit enter here, and we're at 1.82, right? And then if you remember, we've had another 0 at 4.9, so where are we when that velocity goes to 0 again? So it's at 4.91, isn't it? And enter, and we get that value, so negative 4.82, I recorded that. And lastly, we want f of 2 pi. And I think you might be a little bit surprised what that comes out to look like, but f of 2, and if you want to, you can use this button right here, pi, and it's 0. So we have those values, right? All right, so let's go back and see what we get. So we're asked to draw this thing out, right? So we're going to draw it. So we're asked to draw this path, right? So this is what I'm going to say. At time equals 0, s is position is 0. So I'm just going to put a point here. And then the next point that we're interested in is when time equals 2.03, right? So we go over to 1.82, right? And this thing goes this way. This is time equals 2.03, and at time equals 2.03, our position equals 1.82, doesn't it? Isn't that right? And then what happens is this, right, we're at velocity of 0, so this thing comes around, and this is the way they like you to draw this for the AP Calc exam. I'd like you to draw it like this. The reason I don't care for this that much is because it looks like what we're going to get is we're getting height, but we're not. This is only horizontal movement. But at time is 4.91. Let's look at this for a second. At time is 4.91. Right, we have negative 4.82. Good. All right. So here, time equals 4.91, but position equals negative 4.82, doesn't it? But we also, the reason that this is an important place for us is because we know that that is where velocity goes to 0, so we're going to head back, aren't we? We're heading back. And what we find out is if we go to time as pi, so when time is pi, position is also 0, and we did that proving with the calculator, right? So here are all those places. So now what we need to know is the distance traveled by the particle greater than 10? Well, let's look at the distances. The first distance we have is this one, right? And this distance is between 0 and 1.82, so that's 1.82, right? The next distance we have is this one right here, right? And that's from 1.82 to negative 4.82, which is 6.62. Is that good math? Let's try it. 1.82 plus 4.82 is equal to 6.64. Is that right? So plus 6.64, right? And if you think about this, how do you find distance? You take the second value minus the first one, so you have 1.82 minus this, so it makes it plus, doesn't it? And then we're going to go from this right here back to 0, right? Which is another, right? We're going from here, which is negative 4.82, all the way back to 0 because we know at 2 pi. So we need this distance right here, and that distance is, again, 4.82. So when we added all those together, we got a value of greater than 13, I think. So it's definitely greater than 10. So this is our support for this. All right. I hope this is helpful. What I really hope is that you're messing with this calculator, trying to make it do the work for you, and getting really good at it. There won't be time on the AP exam for you to get good at doing this work. So you're going to have to do it now. And also, let me caution you one last time. When you're allowed to use your calculator on the free response section of the AP exam, please do not write, I used my calculator. They are really expecting you to give some good support, and this is the support. This is how I would do this. All right? If you have questions or comments, please let me know, and I hope that you're subscribed to my channel. Peace.